Here's the review for probability. Number 1 says Billy has a coin and a number cube. The number cube is labeled 1 through 6. So we want to go ahead and write out 1 through 6. He also flips a coin once and rolls the number cube once. So when you flip a coin, you can get heads or tails. What is the probability that the coin lands heads up? So let's underline heads up. And the number cube lands on a number less than 3. So that would be 2 and 1. So since we have two separate events, we have the coin flip on the right side and the number cube on the left side. For the coin flip, we have 1 heads out of 2 possible outcomes. For the number cube, we have 2 outcomes that are less than 3 out of 6 total. Now we can reduce the number cube 2 over 6. If we divide each by 2, we can get it down to 1/3. Now, when we have a problem, and it's talking about probability and it has the word and, that means we're going to multiply the 2 fractions. So we have 1/3 times 1/2. When we multiply straight across, 1 times 1 is 1, 3 times 2 is 6. So we end up getting 1/6. Number 2 says a bag contains 10 red marbles. So let's write that out. 10 red, 15 green marbles, 15 blue marbles. If Cam draws a marble from the bag, what is the probability that it is a red marble? So the first thing we have to do is find out how many total marbles we have. So we have 15 and 15, that gives us 30. 30 and 10 is 40 total. So since we have 40, that is our bottom number in our fraction. When we are looking for probability, we need to have a fraction. Now, it is asking for the red marbles. So red is right here. I have 10, so that is my top number. Now I can reduce this fraction. I can divide by 10 on both of them to get 1/4. That would be my answer. Here's number 3. Riley and Lydia went to the movies with their mom. There were several snacks to choose from at the concession stand. There were 2 bags of popcorn. So let's write 2 popcorn. There were 3 gummy bears. So let's write 3 gummy. And there was 1 chocolate bar. What is the probability? That's a clue word right there. Probability means we're going to have a fraction of Riley getting a bag of popcorn. And that's the other word we were looking for. That means we're going to multiply Lydia getting a chocolate bar. So first things first, we need to find the total number of items. 2 and 3 is 5. 5 and 1 is 6. So there's 6 total items at the concession stand. We know we said we were going to have a fraction. The first fraction is talking about a bag of popcorn. So we see that there's 2 bags of popcorn right here. So that would be our top number, 2. Our bottom number is the total number of items that we have. So that would be 6. Now we can reduce that. We can divide each by 2 to get 1/3. Now that is an answer choice, but we know we have to do more to the problem because of this word right here, and. So let's cross out 1/3 because that's the tricky answer. Now let's continue. We took away that popcorn, so now there's only 1 popcorn. Riley has the other one. Since there's only 1 popcorn, our total number goes down to 5. So now we need to do another proportion because Lydia wants a chocolate bar now. So there's 1 chocolate bar out of now 5 total items. Remember when we use the word and up here, that it is multiplying. So we now need to multiply the two probabilities to get 1 times 1 is 1, 3 times 5 is 15. 1 over 15. Number 4 says Stephen has 2 different spinners. He spun each spinner several times and recorded the results in the tables below. Based on these results, if Stephen spins each spinner 60 times, which of the following is the best prediction of his results? So first things first, we got to total up how many times he did each spinner. For spinner 1, we can add these all together. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 6 is 20. Now for spinner 2. 2 plus 2 is 4. 4 plus 1 is 5. 5 plus 5 is 10. Now these are both the totals for those spinners. Now we need to get those results somehow to be 60. So for 20, we have to multiply that by 3 to give us 60. So since we multiplied the total by 3, we have to multiply each other by 3 to make the problem correct. So 8 times 3 is 24. 4 times 3 is 12. 2 times 3 is 6. 6 times 3 is 18. If we were to add all of that up, it would equal 60. Now we need to do spinner 2. To get 10 to 60, we have to multiply by 6. So we're going to do that to every answer up top. 2 times 6 is 12. 2 times 6 is 12. 1 times 6 is 6. And 5 times 6 is 30. If we were to add those up, we should get 60 as well. Now, each of the answer choices down here are comparing spinner 1's orange. So that's right here. Comparing this column to spinner 2's purple. So we're comparing these two. Now the answer that we're really looking at is right here. Now let's read through our answer choices and see if we can find something that matches. A says spinner 1 would land on orange 6 more times than spinner 2 would land on purple. Well, right here we see that they're both 12, so A would be wrong. B says spinner 1 would land on orange 10 more times than spinner 2. Again, they're the same, so that's wrong. C says spinner 1 would land on orange twice as many times. Again, they're the same. And the last one, spinner 1 would land on orange the same number of times spinner 2 would land on purple. That would be our answer because those are the same. Here we have number 5. Donald has 4 marbles in a bag. He has 2 red marbles. He has 1 blue marble. And he has 1 green marble. He draws 1 marble from the bag without replacing it. He draws another marble. Which list, tree diagram, or table represents all possible outcomes of this experiment? So to do this, I'm going to figure out all the different combinations. So if I were to go red to blue, I'm going to represent that by RB. Now, I already have that connection, so now I'm going to go red to green. And now I'm going to go red to red. Because we are drawing 2 marbles without replacing the first one, so it can't be that same red. So we have 3 outcomes right there. Now, let's start with the other red marble, if we were to draw the right marble first. So we have, again, red to green. We have red to blue. And red to red. we have some more that we can add in. So we need to start with the blue. So starting with the blue, we have blue-red. We have blue-red with the other red marble, and we have blue-green. And we need to start with the green now. To get all the possible combinations, we have to start with each marble being drawn first. So now it's the green's turn. We have green, blue. We have green, red, and green, red. So now we need to count up how many total outcomes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 different outcomes. So each of our answers should have 12. If they don't, they would not be correct. Looking at A, we can count up the outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So A right now, looking pretty good with 12. Let's look at B. 1, 2, 3, 4, 5, and 6. So that's only half, so B would not be correct. C only has 1, 2, 3, 4, 5, 6, because one whole row is an outcome. So that's only 6, so C is wrong. And D, there's only 3 different outcomes: red to blue, red to red, and red to green. So D is wrong. So A would be our answer. All right, here's number 6. A coin was tossed and a spinner with 3 equal sections numbered 1 to 3 was spun. The results are shown in the table. What is the experimental probability that the next toss and spin will result in 1 and tails? So first off, we have to add up all of the numbers to get our final total, because we know when we're looking for a probability, we have to get a fraction. And our total number is always on bottom. So we have 6 and 4 right here equals 10. 10 and 8 is 18. So let's write the 8 and carry the 1. We have 1, 2, 3, 4, so we get 48. 5 plus 7, we get 12. So we'll put the 2, carry the 1. 2, 3, 4, 5, so we get 52. Now we add 48 and 52. 8 and 2 is 10, carry the 1. 1 plus 4 is 5, 5 and 5 is 10. So we get 100 as our total. So our bottom number in our fraction is going to be 100. Now we need to read the problem, and it says result in 1 and tails. So we follow 1, we follow tails. So here's 1, here's tails. They only overlap in one spot. That's right here, 20. So that is our top number in our fraction. Each of these can be divided by 20. If you're not sure, you can always do the smaller number. 2 would be a good place to start. 20 divided by 20 is 1. 100 divided by 20 is 5. So we get 1 out of 5. Number 7 says Pablo recorded the colors of cars driving by his house. The table below shows the colors of the last 250 cars to drive by Pablo's house. Using the data, what is the probability that the next car to drive by Pablo's house will be red or blue? So we should add up all of our numbers. It does give us the number here, but let's add up just to make sure. All of the zeros still equal 0. We got 7 and 3 is 10. 8 and 2 is 10. 10 and 10 is 20. 20 plus 5 is 25. So we do get 250. So that should be the bottom number in our fraction. Now, it wants us to use red or blue. Okay, this right here is very, very, very important. Red or blue. So that means we have to add the red and blue together. So 50 plus 70. When we do that, we end up getting 120 as our top number. We can divide each of those by 10 to get 12 over 25. That would be our answer. Here we have number 8. It is a very long problem and it does take some time, but if you read it carefully, it is a pretty easy problem. It says Maddie's piano book includes 15 songs in the key of C, 10 in the key of G, and 5 in the key of F. The 3 songs from all keys appear in random order. Over the past month, Maddie has randomly opened his piano book to a song in the key of C 80 times, the key of G 30 times, and the key of F 10 times. What are the theoretical and experimental probabilities that the next song Maddie randomly picks will be in the key of G? So that's a lot of information to break down. We know that we're looking for theoretical and experimental probabilities. So that's 2 different types of probability. We know experimental is when we actually do the experiment and try out what we're looking for. Theoretical is based on the numbers, what we predict could be true. So let's start with theoretical. So we have the book includes 15 songs in C, 10 in G, and 5 in F. So let's add those together. 15 and 10 is 25. 25 plus 5 equals 30. So our bottom number in our fraction, because we are still doing probabilities, the bottom number in our fraction is 30. Now, in our question, we see that it's talking about the key of G. We are looking for the key of G. So we look at the number right here to see that it is 10 for the key of G. We can reduce that by 10 to get 1/3. So the theoretical is 1/3. We see that here and here. So that means B and A we can eliminate. Now let's do the experimental. That's when we actually do the experiment. So we see the key of C. Let me get a highlighter. The key of C 80 times. The key of G 30 times. And the key of F 10 times. So we need to add all of those up. 80 plus 30. That gives us 110. Then we need to add 10 to get 120. So that's the bottom number in our fraction. Again, we're doing probability, so probability means fraction. And it wants the key of G, and we see the key of G is 30 times. So 30 is our top number. We can divide each of these by 30. 30 divided by 30 is 1. 120 divided by 30 is 4. So 1/4 is the experimental probability. So that makes our answer D. Number 9 says, in a factory, a sample of 40 light bulbs was selected from a box of 1,000 light bulbs. In the sample, 2 light bulbs would not work. Based on this sample, how many non-working light bulbs would be expected in the group of 1,000 light bulbs? So here we're trying to figure out a certain number. When we are trying to figure out numbers, I like to make proportions. A proportion is when two fractions are set equal to each other. So we know that 2 out of 40 light bulbs didn't work. And we're looking for how many light bulbs out of 1,000 wouldn't work. So here we have our proportion, and we did that just by reading. We knew that 2 and 40 went together because those are the smaller numbers. They typically go together. The sample was 40. Out of the 40, 2 didn't work. So we know 1,000 is our total that we're looking to work with. Once we get our proportion, we cross multiply 1,000 times 2 and get 2,000. Then we divide down. 2,000 divided by 40. If you're not sure what goes in, always remember TIBO, top in, bottom out. So the top is the 2,000, bottom is our 40. 40 goes into 2, 0 times, into 20, 0 times, into 200, 5 times. And that is 200. We subtract and get 0, but we still have to bring this 0 down. 40 goes into 0, 0 times. So we get 50 out of the 1,000 light bulbs would not work. Number 10 says, use the picture to answer the question. One marble is drawn at random from each bag. What is the probability, clue word, we are going to need a fraction, that neither marble is blue? So since we have two different bags, we're going to need two different probabilities. So we have a probability over here and a probability over here. So we're looking for the probability that it is not blue. So we are looking in each bag to figure out how many are not blue. In bag 1, we'll label this 1, and this one 2. In bag 1, we have a green and a purple. So that is 2 out of 4 total marbles. If we reduce that by 2, we can get 1/2. In bag 2, we have a white marble and a white marble and a purple marble. So we're looking for how many are not. Okay, so that is 3 out of the 4 are not. Now, when we have two different fractions or two different probabilities, we multiply them together. So we have 1/2 times 3/4 to give us 3/8 as our answer. So the probability that neither marble is blue is 3 out of 8 chances. So here's number 11. It says, use the tree diagram below to create the sample space from flipping 3 coins. Then determine the probability of flipping exactly 1 head. So we need to go through and figure out how many only touch 1 head. I'm going to go ahead and label each of the final outcomes to make answering this question easier. So I'm going to follow the trail. We start at the top. We will go heads, keep going, heads to heads. So that's 3 heads, so I'm going to put H, H, H. Now I'm going to go again. I go, start at the top, heads, heads, tails. So I'll go H, H, T. Start at the top again, heads, tails, heads, heads, tails, heads. Start at the top, heads, tails, tails. So we got heads, tails, tails. Now I'm going to keep doing this. I'm going to go a little quicker. So going the other way, we have tails, heads, heads, tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Now we need to go through and highlight which one of those only has exactly 1 head. So the first one, that's 3 heads. We have 2 heads, 2 heads, there's 1 head. So let's highlight that. Keep going on, 2 heads, 1 head, let's highlight. Keep going. One head, we're going to highlight again. And the last one, no heads. So out of the 8 total outcomes, 1, 2, 3, 4, 5, 6, 7, 8, we only have 3 that are 1 exact heads. So let's go through and look. We know 8 has to be our bottom number, so we can eliminate this and this answer. We know there's 3 that have only 1 head, so our answer would be D, 3 over 8. And our last one, number 12. Suppose a fair coin is tossed and a fair number cube is rolled. What is the probability that the coin lands on tails and the outcome of the number cube is less than 3? So we know a number cube has 1, 2, 3, 4, 5, and 6, and a coin has a heads and a tails. So those are 2 separate events. We're looking for the probability. So we know we're going to have some fractions. And it says the word and, so we know we're going to multiply. So we're going to have 2 fractions and we're going to multiply. Now, it wants to know that landing on tails. So landing on tails, so that would be this one. That is 1 out of 2 outcomes. The other thing is that the number cube is less than 3. So 2 is less than 3 and 1 is less than 3. So that is 2 out of the 6. Now that can be reduced to 1/3 if we divide by 2. So then we multiply. 1 times 1 equals 1. 3 times 2 equals 6 to get 1/6.